So let's first start by discussing the problems that I gave the previous day. Okay, we will skip the ones which everybody could do. I'll only discuss the ones which someone could not do or which was interesting for someone. Yes. So let's start with the first question. Okay.
Yeah.
So let's start with the first question. Find explicitly the system of this thing. Yeah. So let me first tell you the context of the question. Okay. So last time we discussed that if you are in R3, for example, right, then any subspace, we showed that it is equal to the solution of a system of linear equations. Is that right?
Yeah.
Debanjan, do you see what I'm saying? Um,
Yes, sir. Yes, sir. Yes, sir.
yeah, right. That was the
Yes, sir.
milestone that we had reached. Yeah, that any subspace,
Oh,
no matter how you define it, eventually you can define it using eventually it will be some solution of some system of equations. That was the context. So with that context in mind, I have asked you to actually just demonstrate that thing for this subspace generated by one thing. Okay, by
hmm.
one vector. Okay, so could everybody do this one, or is everybody confident that they can do it? Otherwise I'll just skip it. Okay.
So I did not get that idea of subspace generated by a single vector. I mean, a single vector can generate quite different types of subspace. So
Oh, no, let's see. Yeah,
I
let's see that. Okay, no problem. So here you have 1 comma 0 to 2. Okay, now subspace generated by this, subspace generated by 1 0 2 and 2. No, there will be a unique subspace, right? So of course, when I mean subspace generated, I mean over R. I think I mentioned R4, so it's over R. So the elements of the subspace that would look like,
Alpha 0 to alpha to
absolutely, yeah,
alpha.
alpha
Yeah.
0 to alpha, comma 2 alpha.
Hmm.
Okay, Debanjan, I hope this is clear then, right?
oh, sir. Oh, so the single line. Okay, sir. Okay, sir. Now I got
Yes,
it.
it will always be a single
Okay, sir. I'll
element.
be able to solve it.
Yeah, so
I'll be
you
able to
should,
solve it now.
yeah, but please do the calculations, and you don't have to show it to me, but do the calculations and make sure you can get.
So I have
Okay,
found a
sir.
linear equation that satisfies this for any alpha, but is that the way or?
No, see,
Hmm.
one linear equation will never do the job. You will need three linear equations. Okay, so let me write the question. Okay, write uh just 1 second. Write a system of equations whose solution, just again, sorry for interruption, just 1 second. One of the students is messaging, so I have to just reply to him. Yes, so write a system of equations whose solutions is exactly this: alpha to alpha to alpha. Okay, of course this is an infinite set, right? Yeah, so you
Hmm.
see, one equation will never do the job. Okay,
Yeah,
because
one equation that satisfies this but is has more values is I found that. Mhm.
yes, so similarly you have to find more equations so that the intersection of the solutions is exactly this.
Yeah,
Okay,
I
for example,
understood.
you
Yeah.
remember in the three-dimensional case, we had seen that, for example, if this was in three dimensions, just for a second, if you forget about this other two, if this was like this, then 1 comma 0 comma 2, let's first set up the context. 1 comma 0 comma 2 then would be like somewhere on the xz plane, like a vector space will be like this, right, extending in both directions. Okay, so for this you will need two planes, right? You will need two planes which when cut will do the job, right? So I mean, you could take, so for example, you could take the xz plane, right? You could take this plane itself, right? The xz plane, xz plane, right? And then you can take any other plane which passes through the line 1 comma 0 comma 2. Okay,
Hmm.
so you can take that some other plane like that, and the intersection of those two planes would be your answer. But this is the intuitive approach. I had also shown a technique to do this, right? By taking perpendicular vectors you can do it, or by the no, you can just write the subspace like this is the subspace, right? This, and so your x1 is equal to alpha, your x2 is equal to 2 alpha, your x3 is equal to 2 alpha also, right? So from here you have to just eliminate the alpha i's and get your equations, right? So what do you get? 2 x1 is equal to x2 and x2 is equal to x3.
Hmm.
You get two equations, and probably you'll get one more equation, right? You have to write something else like, okay, I am sorry, x3 is equal to 2 alpha and x4, so x3 is 0,
X2 is 0.
x3. So this is your three equations. That's it. The
Hmm.
problem is done. It's actually simple, right? Okay,
Hmm.
and so there are several techniques to do this, but the real core is I mean, what I feel from a geometric perspective is that you should be able to see why it is happening, at least, I mean, in three dimensions, not at least, but probably only in three dimensions. Okay, that there are
Yeah.
many choices of planes to take, and wo plane ko I'll cut the planes and I will get my answer. Okay,
Yeah.
this is I had explained this from a logical and model theoretic perspective also, that why you need planes, why you need to describe this vector space as a solution of this, right? Because this is now becoming a defined, this is like set of sentences and so on in a language. So this is a much better set, it's a definable set. But anyways, let's not go into that. The point is that we can do the question. Okay, so I think it's okay, clear for everyone. Just forget about this calculation I did. Just do it on your own. Take some other vector and do it on your own. Very good. Okay. So I think someone has sent me a message. Yeah, Anish. Yeah, Anish. So my question basically is to you then first. So my question is that were you able to do the first question? That is the thing. If you were able to do it, then because then I don't need to tell you anything. Yeah.
No, sir, I wasn't able to do
Oh, you
that.
were not able to do. Okay, no problem. So, okay, let's see. So I'll just repeat the thing. Okay, there's no problem because I think it's a good idea itself. So, okay, forget about that four dimension thing. Let's say if I just gave you three vectors. Okay, now the subspace generated by this. So I'm writing less words. So the subspace generated by this is this, right? And that would be equal to alpha, comma 0, comma 2 alpha, right? Where alpha is in R, right? I think this is clear for you, right? And that subspace would look, you would know exactly how it would look, x, y, z. So it doesn't have a y coordinate. So it is just on the x, z, right? Its projection on the xz axis is just the same vector itself. Okay, what we are talking about. So this much is clear. Now you remember the previous day we were saying that a subspace can be defined, a subspace is usually defined by starting some vectors and taking their linear combinations, isn't it? All possibilities, all adding, doing all kinds of um, additive arithmetic on the set. Okay, so when you take an element, you take a vector, you take a subspace generated by this. We said that this is one way to describe a subspace, but this is not defining a subspace in the sense that it's not constructing a subspace. Okay, so just like when you say something is constructed, it's a cutting of two angles, and so you say the angle bisector is constructed in that sense. And I had taken some other logical detour from there and so on. Okay, but the end thing is that we want to define this subspace, as a solution of system of equation, right? You see my point? Okay, so now how to do this? That's basically the idea, is that if you want to, so basically you want to write some equations whose solution would exactly be this subspace. Okay, so intuitively it's very clear, right? You can just take two planes whose intersection is this line. That's like a high school question, in class 12 vector kind of question, right? You just take two planes whose intersection is this line. That's one way to do it. You can probably just take any two planes which will just roughly work. You can figure it out. However, the way I had means algebraically got it is that your subspace, first coordinate of your subspace would be alpha, second coordinate would be 0, third coordinate would be this parameterization, right? And now basically you want to get equations from here, and equations should not have alpha, right? And so you can just do it, right? The one equation is already here, and second equation is just 2x3 equal to x1. So this is your two equations, and these two planes intersection will exactly be that vector. That is also very clear. So is it clear for you, Anish?
Yes.
Yeah, okay, very good. So now let's quickly move to the next question then. uh, you can probably just take some more examples on your own and just try. Okay, and of course we will do this properly later on, means how many exactly, how many equations you will need when when some number of vectors is given. But for that we will have to study things more before we can say all that. Okay,